So in previous class, what we discussed the magnetic field due to a circular loop, and we got to know that the magnetic field due to a circular loop exists at the center in terms of the straight line perpendicular to the plane of the coil. In whatever plane the circular current carrying coil will be placed, perpendicular to its direction, the magnetic field will be present, right? So, and based on the direction of flow of current, the direction of magnetic field will be decided. So if the current loop in such a way, so we are going to discuss right now direction of magnetic field due to a circular current carrying loop or coil. So for this, although I have already discussed these things in the first class directly, once I describe the direction due to the straight wire, that time I already mentioned the direction of magnetic field once again. So, but still, at particular this time, we are going to discuss how we can find the direction of magnetic field. Yesterday, we got to know that if the current was flowing in the anti-clockwise direction, like this. So, if the current is flowing in the current loop is kept in the XY plane and current is flowing in anti-clockwise, this is clockwise direction, so let it be. If the current is flowing in clockwise direction, first let's discuss clockwise direction, then in next we'll check the anti-clockwise direction. So let's suppose this is the loop, current loop, and in this current loop, current is flowing in anti-clockwise direction. So this is anti-clockwise direction. Which thing is flowing? Current is flowing. So current is flowing in an anti-clockwise direction. The current carrying loop is kept in the XY plane, and we need to find the direction of magnetic field because both of them. Right. So if the current is flowing in the clockwise direction, then we got to know by previous class the magnetic field was lying at the center point O in a straight line and perpendicular to its plane. It means it was lying inside perpendicular to it. So direction of magnetic field at the center is called cross. What we say? Cross. Cross means inward direction, right? Perpendicular direction, inward to the plane. Inward means inside. So whenever we need to present the inside direction of this plane, we will be using the symbol cross. So direction of magnetic field is inside to this XY plane, that is minus Z axis, inside this. So how we can represent it? By cross. Let's suppose now the current is flowing in anti-clockwise direction in such a way, then we got to know that the magnetic field was present at the center O in terms of a straight line near the center O, and it was coming out. All the magnetic field lines near the center O, net magnetic field line was coming out to the perpendicular to this plane. And for this, we say the direction dot. Please don't confuse with this. This is the point O. This is the center O. And the direction of magnetic field is dot. Dot means perpendicular direction outward to the plane. You can say this can be treated as positive along the positive z-axis. You can say it can be treated as along the minus z-axis. Got it? So these are the two directions. But every time how we can find it? So for this we have some rule, although not mentioned in your book, but let's check it and you may remember by this. So what you need to do? You need to take your right hand. This is again the right hand rule. Right hand thumb rule was being used in to find the direction of magnetic field due to a straight wire in which we keep our thumb in the direction of the flow of current, and the curling of the fingers was representing the direction of the magnetic field, right? So if the current flows in a straight wire in such a way, the magnetic field was in circular pattern, and since if I'll keep my thumb along the direction of current, then curling of my fingers is showing me this direction. So arrow will be taken along according to the direction of moving of fingers or curling of fingers. Now here we need to do it opposite. Why opposite? Because initially the current was flowing in a straight direction. That's why our thumb was kept along the direction of current, and curling of fingers was giving the direction of circular magnetic field. But here the current is circular. So how we can do it? Now move your fingers, then the straight direction of your thumb will give you the direction of magnetic field. So here, if I'll move my fingers, curl my fingers according to this, so then stress thumb is coming where? Inside the plane. See, inside. So magnetic field will be inside. Remember, we need to use right hand only. So take your right hand, curl your fingers, move your fingers in the direction of flow of current, then the stress thumb will give the direction of magnetic field. So if I curl my fingers, then obviously my thumb is showing the direction inward, perpendicular to this loop. So that's why inward direction. Similarly, if I show the direction of magnetic field here the current is flowing in anti-clockwise direction. In anti-clockwise direction, if I curl my fingers, move my fingers, then thumb is coming out to this plane, perpendicular to this plane. So that's why this is dot. All right. Now, these are the direction of magnetic field. Now, how we will say which one of them should tell you the direction of magnetic field as well as the pole? Means if you are looking at this loop, then which portion of this loop? For example, if I say this is the loop, current is flowing in such a way, in which direction? Clockwise direction. Clockwise direction, no? Yes. Sorry, anti-clockwise direction from your side. It is anti-clockwise direction. So if I'll move my fingers, then magnetic field should be outside to this plane towards you. So in whatever direction, this tip of the pen will show you or will be there, it will represent the north direction. So anti-clockwise direction, or you can also say the anti-clockwise direction shows the north pole, and clockwise direction shows the south pole. If we are looking in front of it, obviously then the opposite backward side will be the opposite pole. So if this is the anti-clockwise direction, you are able to see it from front, then this direction is, and direction is the tip of this pen is coming outward to this plane, then it should be the north pole. Then obviously the backward portion which you are not able to see, you have to see it, then you have to come in front of it in the back side. Then the pole lying backward to it will be the south pole. Always north and south will exist in pair. They can never exist monotonously. It means they can never exist as a single pole. So if in front of it this is south, then backward to this north will be there. If you are able to see this direction from the front, this is north pole, then backward to this should be south pole, right? Now again, so this is the rule. That's how we find the direction. That's how we find the direction of magnetic field, and north pole will give you anti-clockwise. How you can remember NT, N pronunciation comes as N. N means north, N means NT. Pronunciation wise, NT, N north, right? Another way to remember this, if you'll draw the symbol north and south in the clockwise and anti-clockwise. Let's suppose this is clockwise. Then one of them can be shown according to the flow of current. So in whatever manner the current is flowing, only one type of symbol can be drawn inside it. See how. Either inside it I can draw south in such a way that these endpoints of south and these endpoints of north should match with the arrows of the current. So see, let's suppose if I'll draw the south here in such a way. So see, you can check it. This arrow and this arrow in same direction. Here this arrow and this arrow in same direction. So yes, this is for south pole. And south pole is representing which direction of current? Clockwise. Clockwise. Similarly, if I check it here, or let's suppose someone say, no, if I want to draw the south here. Okay, try to draw it. If you'll check it, this arrow is coming down, this arrow is going up. Both are in opposite direction. It means you can't draw south in this, right? What do you need to draw now? You need to draw north only. So check it in that way, draw the north. So check it, this arrow and this arrow, both are in the same direction. This arrow, both are in same direction. Yes, it means they are matched. It is the trick just to remember. This is not a rule, it is just the trick, so that you can easily find out which direction of flow of current will give you which type of pole of magnetic field. So if the current is flowing in the anti-clockwise direction, NT, N, obviously, and you can draw the N as well. So north pole. North pole means whenever the current will be flowing in the anti-clockwise direction, north pole will be existing in front of it, if you are directly seeing it, right? So this is north pole. North pole will be found for anti-clockwise direction and south pole for clockwise direction. I guess the directions are pretty much clear to all of you. How many of you understood properly? All right, so afterwards we'll be seeing now the solenoid. Okay. Okay, one more thing which we need to remember in these situations, that the strength of magnetic field depends on certain parameters. What are they? If the current flowing will be increased, then the strength of the magnetic field near the center will also increase. And if the current flowing in the circuit, in the circular loop, will be decreased, similarly, the magnetic field will also decrease. It means the magnetic field is said to be directly proportional to the flow of current. As whenever these kind of relations comes, y directly proportional to x. So if this quantity would be increased, in the same manner, this quantity which is depending on it will also increase. And whenever this kind of relation comes, y directly proportional to 1 upon s, inverse relation. So if the denominator quantity will increase, then another quantity depending on it will decrease. That's why this is inverse relation. So remember, whenever current will increase, it is found that, practically it is found that the strength of magnetic field increases. How we can check it? By placing a magnetic needle near to it. If we'll place a magnetic needle near to it and will increase the current flowing in it, then it will be showing more deflection as compared to previous one, if the current would be increased. So more deflection, that means more powerful magnetic field near to it. It means as we increase the current, magnetic field also increases. And as we decrease the current, the deflection will be less and less. And that's why we can say the magnetic field decrease as we decrease the current. And hence, so one parameter on which the strength of the magnetic field or magnitude of the magnetic field depends on is current. So magnitude of magnetic field is directly proportional to I. Why always I am talking about the magnitude? Because right now we are not talking about the direction. We are just talking about its value, amount. That amount will increase or decrease. Getting this? Similarly, what is the next parameter on which the magnitude of this magnetic field can increase or decrease? If instead of this 1 turn, if I'll take so many turns of wire, conducting wire, for example, have you seen the windings in ceiling fan? If you have opened it or somewhere, if you have seen it or in some motor, there are insulated copper wire windings in circular patterns. So if more and more turns will be there in each turn, let's suppose this is 1 turn, then near to it another turn, near to it another turn, near to it another turn. Since in each turn same current I will be flowing. So with respect to one loop, if one B is there, then with respect to second loop, another B will be there, third loop, another B will be there, fourth loop, another will be there. So overall, we can think this whole system is made up of 4 turns as a single 4I. So as the current has been increased because of so many turns, magnitude of magnetic field also increase. So we can say if there are n turns, then B will directly depends on the number of turns or wounding of this wire. So if so many turns will be there in circular pattern, then magnitude of magnetic field will also increase with respect to number of turns. Getting this? Okay. So this was the second parameter. Third parameter depends on the radius of the circular loop. It will increase the radius. Now what will happen? We, by common sense, we know that. What do we know that? If I'll take an iron object near or another any magnet or iron object, or let's suppose this is all pin. If I'll place this all pin here in one case, and in another case I have taken the all pin here, in another case here, case 1, case 2, case 3. So by common sense we know that this case 1, in this case 1, all pin will get the maximum force of attraction because of the magnet. In second case, it will get some force of attraction, but it will be less than to the case 1 and greater than to the case 3. And the case in case 3 situation, the all pin kept at the that much distance, it will get the minimum force among all cases, right? So what we can say, as the distance from the magnetic field increases or source of the magnetic field increases, distance will increase, then magnetic field will decrease. So how they should be related? They should be related inversely. If the distance will increase, magnetic field decrease. Similar thing happens here. Why here? Because we know that the magnetic field is being produced at near the center. So source of magnetic field we can count as at the center. And because of the current as well. So if this is one of the case, then this should be the distance capital R, let's suppose R1. And if I increase the radius R2, then current will be flowing here and here. Then more and more gap will be increased. That's why the strength of magnetic field will decrease. So it is practically found that if you will increase the radius, then the magnitude of, this is the third parameter, magnitude of magnetic field will decrease. That means it is having the inverse relation. Where what is R? R is the radius of the circular loop. So these things you need to remember. How many of you understood these things properly? So let's start solenoid. So आज देख लेते हैं इसकी जल्दी से कंस्ट्रक्शन और इसके बारे में, और फिर इसको प्रॉपर्ली करेंगे. So what is solenoid? Solenoid किसको नाम दिया गया है कि जिस तरह से हमने एक सर्कुलर वायर बनाया, उसकी जगह अगर मैं एक यहाँ पर कोई वायर ले लूं, वायर अभी मेरे पास यहाँ पे अवेलेबल दिख नहीं रहा है, ठीक है, कुछ भी ऐसा मान लेते हैं। ये चलो एक वायर तो दिख गया मेरे पास। ये देख लीजिए, ये है एक प्लास्टिक का, कुछ भी ये मार्कर है प्लास्टिक का है इसका, यानी कि इस पर, और एक ये मैंने एक इंसुलेटेड वायर ले लिया। आपको पता ही है कि चार्जर का वायर है मेरे पास बहुत लॉन्ग, इसके अंदर क्या है, कॉपर वायर है। तो लेकिन इसकी हालांकि कवरिंग बहुत ज्यादा हार्ड है, बट डजंट मैटर, हमें समझना है इससे मतलब ये एक इंसुलेटेड कॉपर वायर ले लिया। इंसुलेटेड का मतलब कॉपर वायर, कंडक्टिंग वायर जिसके ऊपर कवरिंग हो, तो ये इसके ऊपर कवरिंग दिख ही रही है। उसको अगर इस तरीके से लपेट दिया जाए टर्न बाय टर्न, टर्न बाय टर्न, तो जो सिचुएशन बनी, ये देखिए, ये जो चीज बनी है इसी को सोलेनॉइड कहते हैं। तो ये काफी लेंथ में बनानी पड़ती है, उसके अंदर टर्न्स बिल्कुल पास 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 ये। सो अगर एक इंसुलेटेड कॉपर वायर के टर्न्स को इस तरीके से रैप कर दिया जाए, बिल्कुल पास पास जो क्लोजली पैक्ड हो, तो जो सिचुएशन बनी, ये जो सिचुएशन बनी इसी को बोलते हैं, ये देखिए मैंने इसमें से निकाल भी ली, तो इसको आप चाहो तो किसी कार्डबोर्ड पर रख सकते हो। ये देखो, ये एक होलो नजर आ गई होगी, अरे ये गिर गई, खुल गई है ना। तो ये वाली जो सिचुएशन बनती, इसी को बोलते हैं सोलेनॉइड। तो अगर मैं इसको डिफाइन करूं कि व्हाट इज सोलेनॉइड, सो सोलेनॉइड तो कैसे डिफाइन किया जाएगा, व्हेन अ circular coils of insulated copper wires are wrapped very closely when circular coils of copper, insulated copper wire, insulated है copper wires, are wrapped closely wrapped कर दी, are wrapped closely in such a way that its diameter is diameter का मतलब इसकी रेडियस है, इसकी साइज, जो ये सिचुएशन बन रही, diameter is very less than to its length, or in such a way that its length, जो भी ये लेंथ बन रही है, ये लेंथ बनी, वो इसकी डायमीटर से काफी लॉन्ग हो। सो यानी कि इसकी लेंथ वाइज, ये जो लेंथ बनाई है, लेंथ इसकी डायमीटर इतनी सी है इसकी, ये इतनी सी जितना इसे मार्कर नजर आ रहा है, इस साइज से इतनी सी इसकी साइज अगर मैं डायमीटर ले लूं, उसके कंपैरिजन में लेंथ काफी लॉन्ग है, तो ऐसी सिचुएशन को बोलते हैं हम क्या, सोलेनॉइड। ठीक है, तो डेफिनेशन कितनों को समझ में आ गई, ठीक है। सो दिस सिचुएशन इज कॉल्ड व्हाट, सोलेनॉइड। अगेन when a circular coils, a number of turns of circular coils of insulated copper wires wrapped very closely to each other in such a way that their length, then its length is much greater than to its diameter, then this situation or the formed device is known as solenoid, which is wounded on a plastic or a cardboard, that means some insulated material. So ऐसी सिचुएशन को बोलते हैं सोलेनॉइड। हाउ मेनी ऑफ यू अंडरस्टूड प्रॉपर्ली? सो इसका सिंपल एग्जांपल क्या होगा, आप लोगों ने पेन की स्प्रिंग देखी है, वो जो चिट वाले पेन आते हैं, उसके अंदर, हाँ सर, हाँ, जो रिफिल, उसमें एक स्प्रिंग होती है, वो स्प्रिंग को आप मान लो, वो स्प्रिंग ही एक तरह की सोलेनॉइड मान लो। अगर उसको पिचका दें तो वो बिल्कुल ऐसी बन जाएगी ना, इस तरह की। तो जो स्प्रिंग बनी है, वो स्प्रिंग एक तरह की क्या कंसिडर कर सकते हो आप, सोलेनॉइड। अगर उसको बिल्कुल ऐसे रैप कर दें तो बिल्कुल वो पास के पास सट गए, बस उनके ऊपर एक इंसुलेशन कवरिंग करनी ताकि वो शॉर्ट सर्किट ना हो। ठीक है, सो सोलेनॉइड की सिचुएशन आई गेस क्लियर है। डायग्राम अगर मैं बनाऊं तो ये डायग्राम कैसे बनेगा सोलेनॉइड का, कोई सी आप जैसे आपने देखी होगी धागे की जो गट्टी होती है ना, वो जो थ्रेड जिसके ऊपर एक सिंपल सी, वो जो उसको खोल दे तो लास्ट में इतनी सी ये निकलती है। तो या तो वो कार्डबोर्ड की, यानी ये कार्डबोर्ड की कोई सी भी ऐसी सिलेंड्रिकल ये ले लो, या प्लास्टिक का ऐसा सिलेंड्रिकल कुछ ले लो, और उसके ऊपर आप इस तरीके से टर्न्स बना दो। ये मैंने दिखाने के लिए दूर दूर बनाए, ये बिल्कुल एक दूसरे से अड़ करके बने हुए, बिल्कुल सटे हुए, बिल्कुल पास पास, चिपक के, हाँ, चिपक करके। सो ऐसी सिचुएशन को क्या बोलते हैं, जो हमारी ये चीज बन के तैयार हो रही है, इसी चीज को क्या बोला जा रहा है, सोलेनोइड।
सोलेनॉइड।
सोलेनोइड, ये सोलेनोइड। तो ये इंसुलेटेड कॉपर वायर्स हैं, उसके बहुत सारे सर्कुलर टर्न्स बिल्कुल पास पास में। अब ये इसका एक एंड पॉइंट हो गया और ये इसका एक एंड पॉइंट हो गया। अब इसको हम क्या करते हैं, बैटरी से कनेक्ट कर देते हैं, बैटरी से कनेक्ट कर देते हैं। सो जैसे ही बैटरी से कनेक्ट करेंगे, यहाँ की लगा देते हैं ना, यहाँ चाहो तो आप रेजिस्टेंस में लगा दो सिंपल सर्किट बनाने के लिए। सो जैसे ही की ऑन करेंगे, आई करंट विल स्टार्ट टू फ्लो। तो ये करंट कैसे जाएगी, अब ध्यान से देखना, ये नीचे की तरफ से जा रही है। आपके पास है ये ऐसे, तो आप सोचो इसमें देखो मैंने वायर 3D में अगर कनेक्ट कर रखा तो करंट नीचे से जाके ऊपर आ रही है, इधर नीचे से जाके इधर ऊपर आ रही है। तो पहले नीचे से गई और फिर ऐसे ऊपर आई, फिर इसके अंदर ऐसे नीचे से नीचे की तरफ से गई और फिर इधर की तरफ से ऊपर आ रही है, फिर ऐसे नीचे से गई और फिर बाहर आ रही है ऊपर की तरफ, फिर ये ऊपर आ रही है, फिर ऊपर आ रही है, अंदर जा रही है, फिर बाहर आ रही है ऊपर की तरफ। सभी के अंदर ध्यान से देखूं तो फ्रंट साइड से देखें तो सबके अंदर करंट बाहर के अंदर सेम डायरेक्शन में। अगर सेम डायरेक्शन में तो बहुत सारे टर्न्स बन गए। अगर मैं एक टर्न पूछता ऐसा देखिएगा कि इस टर्न को ऐसे शो कर दूं मैं, तो ये मान लीजिए कि ऐसे मैंने शो किया भाई, ये ऐसा, तो ये करंट, ये कुछ लूप ऐसे बना हुआ है, तो करंट इधर से यहां से आई, इधर अंदर गई और फिर ऐसे बाहर आई। तो अगर आप करंट की डायरेक्शन के अकॉर्डिंग, सर्कुलर लूप है, इससे इसका मैग्नेटिक फील्ड निकालना हो तो कैसे निकालोगे, फिंगर्स को इस डायरेक्शन में मूव करवाओगे, तो स्ट्रेस थंब विल गिव यू द डायरेक्शन ऑफ मैग्नेटिक फील्ड, अभी हमने पढ़ा था। तो ये मैंने फिंगर्स ली, इसके कारण डायरेक्शन ऑफ मैग्नेटिक फील्ड इधर की तरफ, क्योंकि ये कौन से प्लेन में रखा हुआ है, ये प्लेन हो गया हमारा, ये वाई एक्सिस, और बाहर ये ऐसे प्लेन, ये वाला प्लेन है। तो इस प्लेन में अगर मैं सर्कुलर लूप रख रहा हूं तो इसके परपेंडिकुलर डायरेक्शन किधर हुई, सामने की तरफ, ये हो गया प्लेन। तो इस मेरे पाम पर मैंने मान लीजिए कि क्या रख दिए, सर्कुलर लूप। कहाँ रख दिया वो सर्कुलर लूप, हाँ ये देखिए ये मेरा प्लेन है, इसमें ऐसे सर्कुलर लूप रख दिया, तो इसकी डायरेक्शन किधर आएगी, उधर सामने की तरफ। इसमें करंट ऐसे फ्लो रही है, तो इसको मैं कैसे फाइंड करूंगा, ऐसे गई करंट, ऐसे आ रही, ऐसे आ रही, तो डायरेक्शन। अब इसके कारण इधर है, दूसरे के कारण देखूंगा तो पहले के कारण इधर डायरेक्शन है, तो दूसरे के कारण भी तो इधर ही आ रही। हर एक के कारण नेट डायरेक्शन इधर की तरफ आ रही है, इधर की तरफ आ रही है, इधर की तरफ आ रही है, इधर की तरफ आ रही है। जिस डायरेक्शन में होता है एरो मैग्नेटिक फील्ड का, उस डायरेक्शन के अंदर बनता है नॉर्थ पोल। तो अगर ये एरो इधर है तो इधर सामने से जब हम देखें ऐसे, तो इधर नॉर्थ पोल और ये वाला हिस्सा होगा साउथ पोल, यानी कि इधर से अगर मैं देखूंगा तो इधर साउथ होगा, उधर नॉर्थ होगा। तो ये सामने ये जो भी बन रही है ये मैग्नेटिक फील्ड